All right, in this section, we're going to take a look at angles formed by secants and tangents. So first, let's define secant. That's a brand new term that we haven't seen before. So a secant is a line that intersects the circle in exactly 2 points. So if you remember, back to the beginning of this chapter, we also called a segment that intersects a circle in 2 points a chord. So if we look at this picture right here, I could say that this line segment between P and Q is a chord, but if I extend it out to be an entire line, then we call it a secant. All right. So there's a lot of information on this page here. Right? So I would write down our definition of a secant and then each of these two properties here. Okay, you don't need to write down everything word for word, but make sure that you get the important information down in your notes. All right, so this first property says if two secants or chords intersect in the interior or inside of a circle, then the measure of the angle formed is equal to 1/2 of the sum of the measures of the arcs intercepted by the angle and its vertical angle. So what that's saying here is this angle 1 here is equal to 1/2 the sum of arc PR and SQ. So we could write that out as 1/2 times arc PR plus arc SQ. Right, so that angle there is equal to 1/2 of the sum of these two angles. Now also, make sure that we don't get these confused with central angles. Okay, these angles that we're talking about here are not central angles because the vertex is not at the center of the circle. This is an entirely different idea than a central angle. All right. The other possibility that we're going to look at here first is if a secant or a chord and a tangent intersect at the point of tangency. Okay, so we're saying they intersect at a point on the circle. Then the measure of each angle is just equal to 1/2 the measure of its intercepted arc. Right? So if we want to look at first angle XTV, so XTV would be this angle right here, we can say that that is just equal to 1/2 of its intercepted arc. So that would be this entire arc right here. Now, again, another vocab idea from the beginning of the chapter. This would be considered a major arc because it's greater than 180. So to name a major arc, we use 3 points. So I could call this arc TUV. So we would say the measure of that angle is just 1/2 of the measure of arc TUV. Right? Then for the other one, for angle YTV, we're looking at this piece. This would be its intercepted arc. This is a minor arc. It's less than 180, so I would only use 2 letters to name that. So I could say that this angle will be 1/2 the measure of just arc TV. All right, so let's do a couple of practice problems with these ideas. So in this first example, right, we've got 2 chords intersecting on the inside of the circle. So this angle is just equal to 1/2 the sum of these 2 angles, or I'm sorry, of these 2 arcs. So we can say x is equal to, like this, 1/2 times 30 plus 55. So 30 plus 55 is going to be 85. So 1/2 of 85 is 42.5 degrees. Okay, so this angle here would be 42.5 degrees. So that means that this angle here would also be 42.5 because they are vertical. And then we could even actually find these two angles here as well, right? Because we could say that this one and this one are a linear pair. But this problem didn't ask us to go that far. So in our other example here, we've got our point of intersection is on the circle. So this angle is just equal to 1/2 of its intercepted arc. So y is just going to be 1/2 of 168, and 1/2 of 168 is 84. So that missing angle there is 84 degrees. All right. Let's do a couple more practice ones with this idea here. So this one, to find angle 1, we can just say measure of angle 1 will be equal to 1/2 of these two intercepted arcs. So 1/2 of 52 plus 40. So that'll be 1/2 of 92, which would be 46 degrees. All right. How about this one? Okay, so on this one's slightly different. This one, we are given this interior angle, and my goal is to find the measure of arc GH. Okay, so I'm going to call that my X. That's what I want to find. Well, my setup is the measure of the angle. Okay, this angle is 45 degrees, is equal to 1/2 of the sum of the two intercepted arcs. So my intercepted arcs are 28 and x. So this would be my setup for a problem like this. Now, to solve for x, well, the first thing I could do is, if I'm multiplying by 1/2 over here, to undo that, I can multiply both sides by 2, right? Multiplying by 2 and 1/2 would cancel each other out, so we get 90 equals 28 plus x. Then subtract 28 from both sides, and we'll get that x is 62. Okay, so on something like this, right, just make sure we're putting the pieces that we're given in the correct spot in our equation. So this time we were given the interior angle, so that's equal to 1/2 the measures of the two intercepted arcs added together. All right. On this one then, we are just finding the measure of angle 3. So since my point of intersection here is on the circle, angle 3 is just 1/2 of the intercepted arc, so 1/2 of 220 will be equal to 110 degrees. So angle 3 here would be 110. All right. Let's do one more example with this stuff. So here, I'm given this angle over here, and my goal then is to find the measure of arc RT. Okay, well, we're just going backwards here. So we can say that, call this x, the angle is equal to 1/2 of the intercepted arc. So again, here to solve for x, I can multiply both sides by 2 and get 148 degrees. So the measure of this arc here is 148. Okay, now again, something that hasn't come up in the examples yet but could creep up is the idea that all of the arcs all the way around the circle are 360 degrees. So if I wanted this major arc here, I could just take 360 minus 148, and that would get me 212 for this arc here. And then that would let me find this other angle if I were to extend this line out here. I could find the measure of this angle by just taking half of 212. Okay? So the final situation that could occur here is if the point of intersection of secants and tangents is on the outside of the circle. Okay, so the first two things we looked at were what if the point of intersection of these lines is on the inside? What if the point of intersection of these lines is on the circle? So finally now we can look at what if the point of intersection is outside the circle? Okay, so what happens? Okay, it's the same no matter which of these pictures occur. Okay, if we have two secants, a secant, and a tangent, or two tangents, the measure of the angle formed, so that would be, we're talking about this angle, and this angle, right? Those are the angles formed, is 1/2 the difference of the measures of the intercepted arcs. Okay, it's 1/2 of the difference. So what that means, for example, here, I can say that the measure of angle P is equal to 1/2 of arc BE, the measure of arc BE minus this other intercepted arc here, which would be AD. So I'm saying here's one intercepted arc, here's the other. So BE minus AD, and that'll get me the measure of angle P. Okay, so let's go through a couple examples here. So in this example, we're trying to find angle MPN, so that's this little angle over here. So to find that angle, measure of angle MPN, that's going to be 1/2 of the difference of the two intercepted arcs. So my two intercepted arcs are 34 and 18. So 1/2 of 34 minus 18. So 34 minus 18 is 16. And then 1/2 of 16 is 8. So that little angle there, angle MPN, is 8 degrees. All right. Let's do a few more. So on something like this, we want to find the measure of angle 2. So in this situation, my two intercepted arcs are 160, this arc right here, and then 80, this arc right here. So to find the measure of angle 2, I'm just going to say that's equal to 1/2 of my two intercepted arcs subtracted. So 160 minus 80, so that'll be 1/2 times 80. So the measure of this angle outside of the circle is 40 degrees. All right. Two more. All right. So on this example, we are missing this arc. All right. We are given this arc, and we are given the angle, but I want to find this arc. So I will call that x, and my setup is that the measure of the angle is equal to 1/2 of the difference of the two arcs. Now, just by looking at this picture, I can tell that the 70 is going to be larger than x. So my setup here will be 70 minus x. All right. So now we just want to solve this equation for x. To do that, I'm going to get rid of this 1/2. So I'm going to multiply both sides by 2. That cancels out. And we end up with 40 equals 70 minus x. I can subtract the 70 over. We'll get negative 30 equals negative x. Then just divide by negative 1. And we get that x is 30, or the measure of arc JP is 30 degrees. Okay, so again, just like on the front, make sure that in this idea we're plugging the correct pieces into our formula. All right. Last example. Here, the only thing I'm given is that this angle is 50 degrees. From that, I want to find the measure of arc LN. Well, I don't know either of these arcs. Okay, so we could start, I guess we can say that it's called the large arc X, and we can call the small arc Y. Okay, so the major arc here, not doing so well with drawing in that arc. So we'll say that that's the major arc, and then the minor arc right there. Well, what we can do is say that the angle is equal to 1/2 times the difference, so 1/2 times x minus y. Well, I could multiply both sides by 2 and get that 100 is equal to x minus y, but I can't solve that any further. Right? Well, something else that I know is that since both of these are tangent, that means that these two arcs would make the full circle. These two would add to be 360. So I could also say 360 is equal to x plus y. And I have a simple system of equations that I can solve. If we remember how to solve a system of equations, there's a couple of ways that we could do it, but this system is set up nicely to use elimination. I can just add these two equations together. If I do that, the y's will cancel out. So if I add these together, I will get 460 equals 2x plus 0y. Divide both sides by 2, and I'll get that x is 230. Well, to get y then, I can just take this answer and plug it back into either of these equations. So I can say 100 equals 230 minus y. Subtract the 230 over. We'll get negative 130 equals negative y. Divide both sides by negative 1, and we get 130 equals y. So we find that arc LN is 130 degrees, and the major arc here, okay, which we would need some other point to name, we could call it LZN, is 230 degrees. All right. So again, remember that your assignment for this is to upload a picture of your notes to Schoology, and then there are some practice problems for tomorrow's assignment on Edulastic. And please, please, please send me any questions that you have. I will be happy to help you guys with any of this material.